Okay. So, today is November 24th, 2011. We're doing a review, midterm review, or mid-chapter review, sorry. We're going to take up 6A from 289. They've given us a graph, and they want us to put it in an equation that's in standard form. So they want a standard form equation. It's got to look like that. So I can put it in either standard right away, but looking at this graph, I have no idea how to do that. Or I can put it in vertex or factored. Now to put it into vertex form, what do I need on this parabola? I need to know what the actual vertex is. We don't. So I can't actually use vertex form right away. Factored form, what do I need to know to put it into that? X-intercepts. Do I have them? Yes. So I can use factored form. So we're going to start with factored form in this question. So we're going to use our factored form to solve this question. Now, for factored form, we need to replace the r and the s. So I'm going to call this point r and this point s. So r is 0. That's the x value of r. And the x value of s is 6. We're going to replace the r and the s in factored form with those numbers. So we have y is equal to a x minus 0, x minus 6. I'm going to simplify now. I'll have y is equal to x minus 0 is just x minus 6. So here's my true factored form because I've simplified. Now, I need to solve for a in order to have this in factored form, which means I need to find a value of x and y. Now, I can use any point along this parabola. In fact, if I knew what the vertex was, I could use the vertex to plug it in. But because they haven't actually given us a definite, I don't know if the vertex is at 3.1 and 7.6. I have no idea if it's a decimal, a whole number. They've given us one specific point, which is 5 and 5. So that is an x and y value I can use. Again, you can use any point along the parabola as long as you know it falls on the parabola. The only one we know other than the x-intercepts is 5 and 5. So I'm going to be replacing the y with 5 and both x's with our 5. A point on the graph. So 5 equals a, x will be 5, and x will be 5 minus 6. 5 equals a, 5 times negative 1. We'll get negative 5a. That's 5 times negative 1 is negative 5. Negative 5 times a is negative 5a. When we bring it over, we get 5 divided by negative 5. A equals negative 1. So now we're in our factored form. We have our a value. Remember I said that this specifically was our factored form here because we simplified it. So we're going to plug a in for the missing value. And we'll have in factored form y is equal to negative 1 x times x minus 6. But this isn't the form they were looking for. They're looking for standard form. And in order to go from either factored form or vertex form to standard form, we expand and simplify. So I need to multiply, expand, and simplify this out. Y equals negative 1 times x is negative x times x minus 6. I'm going to distribute the negative x. We're going to get y is equal to negative x squared plus 6x. So we've just gone, by expanding, we've gone from factored form to our standard form. Oops, not sure what happened there. Now, just to refer to this, what that means is our A value here is -1. Our B value is +6. What is our C value? 0, that's right. I could technically add +0 to the end of this, but it will make no difference in the equation. So we're going to leave it the other way. Page 280, number 7. It's a word problem. It says a basketball is tossed from the top of a 3-meter wall. So let's try to get a little diagram of this. We have a wall. We know the height of it is at 3 meters. And some basketball has been tossed from this point. So it's going up, through, and then eventually is going to come back down. Okay? I'll draw the person throwing it in a minute. So the ball is thrown from this wall. The path of the basketball is defined by the relation, and they give us an equation. This is y is equal to -x squared plus 2x plus 3. Now, right away, I need to figure out what form am I in right now. I'm in standard. Good. That's very important. Now, does anyone remember, because factored form finds us the x-intercepts quickly, vertex finds the vertex quickly, what does standard help us do? There's something it helps us find very quickly. The y-intercept. Because when x is 0, and then we're going to quickly do it in our equation in red here. When x is 0, plus 2 times 0, what is our y-intercept? 3. It's whatever the c value is, which makes perfect sense because if this ball was thrown from a wall that was 3 meters high, that means that will be our y-intercept. This is our y-intercept at the number 3. Okay? So the ball is going to come down and eventually hit the ground. Our y-intercept is 3. We need to find our x-intercept. Now, looking at this, because a is negative, we know it's a parabola that's facing downwards. And because the vertex is above, we're actually going to get 2 x-intercepts, but we got to make sense of which one is truly our answer. One of them is going to be a -1, so that won't be the one we're looking for. Now we have our quadratic equation, where x represents the horizontal distance traveled in meters, and y represents the height in meters above the ground. How far is the basketball traveled horizontally when it lands on the ground? So I'm in standard form, and I need to find what? When it hits the ground, what's that considered in a parabola? What point would this be called? X-intercept. I need to find an x-intercept. What do I need to do in order to get an x-intercept? Yes, I need to change from standard form to factored form. So, we're going to take our standard form, y equals -x squared plus 2x plus 3. And we're going to factor it. Now, what's the first thing I do when I factor? Greatest common factor. I want this to be positive x squared, so I'm going to divide each of these terms by -1. That's going to leave me -1 on the outside, x squared minus 2x minus 3. Now I'm going to use our factoring by product. So we're going to find the factors of the first term and the factors of the last term. Factors of x squared are 1x and 1x, and factors of 3 are 1 and 3. The product of the two needs to add up to -2x. These are our only factors, so we know they're going to work. We're going to multiply across, and I'm going to get 1x and 3x. When I add those together, how would I make -2x? -3. Because we needed to be -2, 1 plus -3 gives us -2. So that means the number we multiply to get the 3, which is 3, we need to make it negative. So in our factored form, we have y is equal to -1, which is our a value. X is going to be the first term in both. And because they're the same, it doesn't matter about putting in opposite brackets right now. It's only when the first terms are different that that matters. +1 minus 3. Now, I'm trying to find an x-intercept, and we know that x-intercepts have a y value of 0. So we'll be replacing y with 0. So we get 0 is equal to negative 1, x plus 1, x minus 3. Okay. I need to get rid of that negative 1. So if we just decide to divide both sides by negative 1, we're going to get 0 equals x plus 1, x minus 3. And now what we need to do is we need to split them. We know one of these brackets is going to have to equal 0 in order to multiply them and get 0. So 0 is equal to x plus 1. 0 is equal to x minus 3. Our two x-intercepts are negative 1 and positive 3. So which of the two makes sense? Does the ball go back 1 or does it go forward 3 if we threw it forward? We've gone forward 3. So our x-intercept is at positive 3 and 0. So it's 3 meters away from the wall when it hits the ground. The other option was negative 1 meter to complete that. And we know that's not our answer. We're looking for the positive 3. Okay, question 10C from page 271. This question asks us to find the vertex of each parabola. Sketch the graph, label the vertex, and 2 other points. Oh wow, this is in depth. So first they want us to find the vertex. So I'm in standard form right now. Which of the forms do we think we want to go to? Vertex. That would make the most sense. We need to go to vertex form. So in order to do that, that's when we get into our completing the perfect square and creating it. So remember, the steps to completing the square is I divide the first 2 terms by whatever a is in standard form. So our a is 5, so I'm going to divide both of these by 5. We get 5 on the outside, x squared minus 6x. Plus 41's outside the brackets. Now, we need to do some of our side calculations here. Our new b term, remember, is negative 6. So that's what we're going to put into our little formula when we have to create the perfect square. Our formula is we take the b value, divide it by 2. So we take negative 6 divided by 2 and square it. That'll give us negative 3 squared, which is 9. And remember, we need to add and subtract 9 inside those brackets. So we get x squared minus 6x plus 9, subtract 9, plus 41. Now the negative 9 needs to come to the outside. And in order for negative 9 to come to the outside, we have to multiply negative 9 by whatever our common factor was. So our common factor was 5. We multiply it by the number 5. We get 5 times x squared minus 6x plus 9. Negative 9 times 5 is negative 45 plus 41. Now, I'm going to simplify the outside. We get 5x squared minus 6x plus 9 minus 4. Finally, the whole point, the reason we did this is because we were creating a perfect square trinomial, which is this type right here. And in order, the fast way to factor it is to find the square root of the first and the last term and take the middle number. So in our next line, it's going to read 5, and it's going to be in one bracket squared. We know by factoring this before, the best way to do this is factor the first and last term. So not factor, square root. Square root of x squared is x. Square root of 9 is 3. So my first term inside the bracket is an x, and my second term is a 3. Whatever is in front of our b, which is a negative, I bring that down. So I bring down the negative term. I still have negative 4. So we get 5x minus 3 squared minus 4. This is now vertex form. And in vertex form, I can very easily find the vertex of the equation. We know that the vertex of the equation compared to vertex form is essentially the opposite of our h and whatever our k value is. So our h value is -3, our k value is -4, and just for good measure, our a value is 5. So the vertex of this is going to be +3 and -4. Okay, now the question actually asks us to graph it. So we have our graph here, and we know that our vertex was at 3 and -4. So my vertex, +3, -4. I have 1 point on the graph. There are 2 ways I can go about graphing this. They've asked me to label 2 more points. I could go back to our standard form, which was y equals 5x squared minus 30x plus 41. And from there, I could go to factored form. And in fact, I would find my 2x intercepts if I did that. Or I can continue the parabola. Now, if you guys remember, our a value is 5. When we normally draw a parabola, we go over 1, and we square it to figure out how much we go up. So I'd go up 1. I'd go over 2, up 4. 1, 2, 3, 4. But because our a value is 5, whatever I go up by, I have to multiply by 5. So go over 1, and 1 times 5 is 5. So I go up 5. 1, 2, 3, 4, 5. So here's a new point. 4 and 1. There's a new point. And it'd be symmetrical on the other side. So we'd have 2 and 1. Normally we go over 2 up 4. 4 times 5 is 20. That's going to be right off our chart. So when we go to graph this, they ask for 2 other points. We have our 3 points of this parabola. We have the vertex.
So when they ask for 2 other points, can you put like 4 and 1 and then...
4D from your review. So this is homework you're going to do tonight. This question says 5n squared. Was it D or B? D? Okay. Plus 13n minus 6 is equal to 0. The question says solve by factoring, check your solutions, okay? So, solving by factoring, that means I need to factor this. First thing I look for is a greatest common factor. Is there one?
No.
No, there is no greatest common factor in these terms. So, I'm going to take the factors of the first term, which are 1n and 5n. Now, if you prefer to change it to x, that's fine. N just represents a variable. Okay? Factors of our last term, which are 1 and 6, 2 and 3. And we know the product is going to have to equal 13n. Now, I'm going to tell you right now that we're going to be using 5 times 2 and 1 times 3. So that's going to give us 10n and 3n. Okay? So 10 plus 3n gives us our 13n. So when we go to put this in factored form, I'm just going to move the equals 0 to the left side now. Still equal to 0. Our first terms are n and 5n. Now, oh, okay. Oh, we have -6. So if we have -6, that means one of them will have to be negative. So, because I cheated and I didn't check and use my check, these two numbers don't multiply to -6. So actually, this is incorrect. So I'm going to quickly just get rid of a bunch of stuff here. Okay, so, but what we could do is 5 times 3 and 1 times 2. That will give us actually 15n and 2n. And if the 2 is negative, which would make this -2, we'll get positive 13n. 3 times -2 gives us -6. The other way, it didn't work. We had 2 positives, and they don't equal a negative. So now we've done this. And always be careful when you do this stuff. I clearly made the mistake when I first started it. So we have n and 5n. Now here's the important part. Because we did 5 times positive 3, the positive 3 and the 5n have to go into opposite brackets. And the 1n and the -2 go into opposite brackets. Now it says to solve by factoring. So what that means is they want to know what does n equal? What are the options? So I would split this equation now. 0 equals n plus 3. 0 equals 5n minus 2. We bring 3 over. N is equal to negative 3. And when we divide by 5, n is equal to 2 over 5. Now the question actually says to check. And I know we've never done that, but this is actually a good idea. Let's check this. So what I'm going to do is I'm going to take my standard form. I'm going to plug these values in and find out if it equals 0 both times. Okay, so this question says to check. So for our check, what we're going to do is we're going to plug in each of these for our n value in the equation. So what I'm going to do is I'm going to start down here and split this beside each other. So in our first one, we'll use n is negative 3. So 5 times negative 3 squared plus 13 times negative 3 minus 6 equals 0. Our other option is 5 times 2 over 5 squared plus 13 times 2 over 5 minus 6 equals 0. We'll solve the left side. This becomes 5 times 9 minus 39 minus 6 equals 0. 45 minus 39 minus 6 equals 0. 45 minus 45 equals 0. 0 equals 0. So that one worked out. Our other one, let's turn 2 over 5 into a decimal, 0.4. Okay, I know you guys are a little more used to using decimals. So 5 times 0.4 squared plus 13 times 0.4 squared minus 6 equals 0. 0.4 squared is 0.16 times 5. I'm going to do that all in one step. 0.8. So we have 0.8 plus 13 times 0.4. 5.2 minus 6. 0.8 plus 5.2 is 6. 6 minus 6 is 0. So the left side and the right side work. So in our check, we know that these are both x-intercepts. And what I'll do is I'll graph it just to make sure.
Sir,
So,
what the heck does that mean?
So I graphed it. I'm zoomed in a little much, so I'm going to zoom out a little. So we know we definitely have a parabola. When we zoom in, we're trying to find the two x-intercepts. That's what the zeros are. And because it's a decimal, I'm going to zoom in even more. And it turns out we are at, we're definitely at 3 and 0.4, which is 2 over 5. So that worked out perfectly. We have our 3 over 0. Those are our two 0 points, so we know they worked.